Okay. Salam alaikum, everybody. Good evening. My name's Paul. Paul Maddox. I thought I'd turn my camera on so that you can see my face. We're going to be talking for the next probably hour or so about some really cool technologies on AWS. So the point of this presentation is really to talk about all the stuff that was released during our reInvent conference last year and around that kind of time frame. And my job as the presenter here is to kind of take you through a whole load of AWS functionality and kind of carve out what my favorite bits are and try and give you a flavor and an idea of how they work. So my name's Paul Maddox. I'm a principal architect at AWS. I've been in AWS for roughly about 5 years now, but have a long background of software development. And my role at AWS is all about helping people build cloud-native applications. So for that, I deal a lot with things like containers, Kubernetes, Serverless and Lambda, and kind of fine-tuning DevOps and software development processes. So my contact details are here. I've got my Twitter there. I've got my email address. If anyone here has any questions over the topics we cover, primarily the chat in this WebEx is probably the best place. But if you don't want to ask your question in front of lots of people, you can also drop me an email or a message on Twitter. Okay, so with introductions out of the way, let me talk a bit about what specifically I'm going to cover over the next hour or so. We had a bunch of announcements at reInvent around things like compute and storage. So some really cool new interesting instant types that will get you better performance or help you save money. And I want to kind of call those out and talk through those. And also savings plans and ways of optimizing your cost on AWS. Then we're going to spend quite a bit of time talking about the updates in the container space. So we're going to talk about our own orchestrator, ECS, and some really interesting updates there. Some interesting new CLI tools that were released, but also about Kubernetes and managed Kubernetes on AWS. That's an area that we've made a lot of improvements to over the last year. The last thing we're going to cover is serverless and Lambda. And I'm going to show you some demos as we go through. I've got a demo of Fargate and Kubernetes. I've got a demo of Lambda as well. And I'm going to show you how easy it is to build an application or an API with AWS Lambda and talk you through some of the new changes that have come with Lambda as well over the last couple of months. We've also got some really cool things that have happened in kind of the app development space, so mobile development. Perfect, thank you. So yeah, we're going to talk through AWS Lambda. We're going to talk through how to build some really cool mobile applications, you know, things like iOS apps, Android apps, and some really interesting functionality we've got there. So let's kick off. Let's start with storage. So what I'm going to talk you through here are a couple of simple but really, really powerful improvements to our storage system. So by storage, I mean things like EBS and S3 in AWS. So one of the interesting APIs that was launched at reInvent is the idea of a direct API for snapshots. Let me rewind that a bit and talk about EBS snapshots in general. When you have a VM, an EC2 instance in AWS, and you take a snapshot, what AWS will do behind the scenes is the first time you take a snapshot, we'll take a full snapshot of that disk. After that, there are incremental changes. And previously, before this direct API was launched, if you wanted to retrieve data back from a snapshot, you'd have to restore it as an EBS volume or access it through an instance, etc. So what we've launched here is a direct API for interacting with the data inside snapshots. So there's an API that will allow you to list the blocks in a snapshot. So a snapshot will be broken up into 512 kilobyte blocks. And then you can list which blocks have changed since the last snapshot you got. And then the get snapshot block will allow you to retrieve the data in there. So what does this mean for you as an AWS customer? If you're an advanced customer, you may want to use this API to build your own backup tooling or improve your backup processes. But even if you're not, a lot of the vendors on our marketplace, third-party applications that handle backups on AWS will start using this API. And as a result, what you'll see is faster backups with EBS and also lower cost as well. And probably more options for granular recovery point-in-time restores. The other storage function that we've launched is called S3 access points. So imagine the scenario where you have an S3 bucket and you want to grant an application access to it, or people. What you would traditionally do in AWS is create a bucket policy maybe on that bucket. And in that bucket policy, you could say, okay, I allow this application or that person to access my S3 bucket. Maybe read only, maybe read write, depending on your use case. That doesn't scale very well when you have lots of applications or lots of different people that want to access the data in that S3 bucket, because they probably shouldn't all have the same level of access. So yes, you could create a bucket policy that has lots of conditions and clauses in it to try and set up that configuration. But S3 access points makes that a whole ton easier. Instead, what you can do is for a bucket, you can create a custom URL for that bucket and apply a bucket policy to that. And that means that if I have an S3 bucket and I have one application, I can create an S3 access point for that and direct all the traffic to that access point and put a policy on it. But I can also create a new access point for other applications or teams with different access controls. So think of this as a really nice way of scaling out access to the same data to multiple different teams or applications. Okay, so that's the storage stuff, the main highlights that I picked out from the storage side. Let's move on to compute. There's a couple of new instance types and processes here I wanted to call out and talk about, because I think that they should allow you to potentially save money or do more with the same amount of compute. So the first one I want to talk about is our new INF1, the INF1 instances. These are all about machine learning. So when you're training a machine learning model, there's a couple of different stages. The first thing you want to do is aggregate, collect, and label the data. Then you want to train your machine learning model. But after you've generated your machine learning model, the next part is to make inferences against that machine learning model. So these would be the predictions. Let's say I've built a machine learning model for fraud detection across my purchase history. My front-end application is probably going to hit that machine learning model and infer whether a particular transaction is high risk or low risk, for example. So these instances feature a specific silicon chip that was designed by AWS that really increases the amount of throughput in terms of inferences that you can do. So if you're doing a lot of machine learning, if you're looking to do inference on the machine learning models, these are a great way of hosting those. The other type of silicon update I wanted to talk about here is our new Graviton 2 processor. So back in 2018, AWS launched our A1 instance. And this was our first Graviton CPU-powered instance. It was the first time ARM, as an archetype, had really made a big headroom into a cloud provider, into a major cloud provider. And it provides We're also launching a couple of others later on this year. So the C6G for compute optimized workloads and the R6G for memory optimized workloads. Again, these use that Graviton 2 processor. And what that means for you is so long as your application can run on an AMD processor. And what do I mean by that? let's imagine you're using Java. Okay, that's not a compiled application. It doesn't, you can run a JVM that's compiled for ARM and run your application in there fine, no problem. Same for things like Python, Node.js, etc. If you're running something that you've developed in C++ or Rust, for example, you'll want to make sure you recompile those applications for the AMD processor. And so long as you can do that, you can take advantage of these super powerful instances. Okay. Next, I want to try and help you save a bit of money in your AWS account. I want to talk about a couple of ways you can do that. So the first one is the Aws Compute Optimizer. This is some really cool functionality that sits within your AWS account, and it looks at your EC2 instances and auto-scaling groups that you have deployed, and it assesses them with the help of a machine learning model. This is what it looks like. You can see here I've got a particular application deployed, and I've currently got it deployed on an M5 2XL. So here we can see that the recommendation is that our instance is too big. We can save money, quite a bit of money, if we reduce that instance size. And you can see here that the recommendation engine is recommending a few different options with different risk levels. But the important thing to look at is the graphs at the bottom, and these show my CPU usage and the recommended usage there. The next thing I want to talk about is savings plans. So savings plans are all about committing to AWS compute and getting discounts in return. So this kind of thing has been possible on the AWS platform for quite a while now with reserved instances. So with reserved instances, you've been able to for a long time to say, hey, I want this particular instance type, size, and family, and I want to reserve it for 1, 2, or 3 years and in a particular availability zone. What savings plans do is they take that same concept and add a whole load of flexibility. So now instead of having to be very specific with your reservations are flexible across any OS, tenancy, region, instance, family, or size. And you can still get very, very good savings discounts, up to 72%. So this is something to definitely check out, especially if you've got workloads that are fairly consistent in their usage. So, not very, very peaky workloads, but you have a baseline performance of instances that are running most of the time. Okay. Next up, I wanted to show you the Ec2 Image Builder. Many organizations that we work with as AWS choose when they're hosting VMs and EC2 instances to have some kind of base image in their organization. Maybe it's a standard Linux image or Windows image, but with your organizational tools built in, maybe antivirus or monitoring tools, compliance tools, etc. Maybe it's gone through specific security controls and governance in your organization. Building those images, there's tooling out there to do that in an open source fashion, tools like Packer, for example. But the feedback we got from customers that should be more automated. It should be a part of the AWS platform. And so that's what we've done with the Ec2 Image Builder. So here's an example. I can take a base image, like Amazon Linux or Windows, or even one of my own base images that I've created before. I can then add in components. So AWS has defined a whole bunch of components that we provide out of the box. So you can see here we've got Python, PowerShell, and also our own Amazon Corretto JVM that we use, and customers do too. You can also build your own custom components and include these in your base AMIs. Next up, you probably want to rebuild this image on a regular basis, update it. So the image builder will allow you to configure a pipeline that's scheduled. So you can have a schedule, build my image every single day and update it. And you can also set things like topic notifications. So whenever a new image is built, it can fire a message to SNS. You can then automatically update your EC2 instances to your new image across your fleet, across your accounts, for example. So really powerful functionality, especially if you have these kind of governance and security requirements of your own custom AMIs. Okay, maybe a good time to pause and ask if there's any questions on the chat. No? Awesome. Okay, So next up, I want to spend some time talking about our AWS Container Services. This is an area that saw a lot of announcements at reInvent. And, there's a lot to take in here. So I wanted to spend a bit of time taking you through my favorite announcements here and actually trying to show you hands-on what they mean for you as a customer. So first off, AWS Fargate Spot. We've had Fargate for a while. It's a really nice serverless way of running containers where you can give AWS the container and we'll run it for you without you having to worry about any kind of infrastructure. We're going to dive a bit deeper into Fargate in a moment, but the key thing for you as a customer here is that we now support spot pricing. And what that means is you can see a huge discount on your costs by bidding on unused capacity in our data centers. So this is a really good way of saving cost. We've also launched a couple of new features and functions for Amazon ECS. So on AWS, we support a bunch of different container orchestration systems. We have ECS, we have Kubernetes, we have customers that bring their own orchestrators, like Nomad or Swarm, for example. ECS has been around for a couple of years now. This reInvent, we brought in some really big improvements that a lot of customers were asking for. So capacity providers and cluster auto-scaling. Can you mute someone? Someone's talking to their family. I'm the only one who can. Okay. So a couple of things, capacity providers and cluster auto-scaling. So previously, before these announcements, if you set up an ECS cluster on AWS, you would create auto-scaling groups of EC2 nodes that would connect into your cluster, and that's where your containers would run. But ECS itself didn't really have any knowledge of the auto-scaling groups. It could see the new capacity was registered into the cluster, but it couldn't control those auto-scaling groups. Now the functionality has been added to actually have ECS be aware and control those auto-scaling groups. What does this really mean for you? It means that you can create some really interesting strategies with things like, okay, I want a pool of compute for my containers, and I want 30% to be on spot and 70% to be on demand, for example. Or maybe I want it so that whenever my cluster auto-scales back in, those instances, those containers running on them are automatically drained and gracefully shut down. ECS will now handle that for you, and that solves quite a big pain point that customers had previously with ECS. The next thing I want to talk about is our Ecs Cli V2. So one of the bits of feedback we heard loud and clear from customers is that there was room for improvement with the developer experience with ECS, specifically being able to control and deploy containers from the command line. So with Ecs Cli V2, this is a brand new CLI that we're launching. And in my opinion, it's the easiest way to run containers on AWS today. So this CLI tool will talk you through in kind of a wizard guided form, deploying your workloads and containers to AWS. So this is an example of the first time I run it. Here it's saying, what do you want to call your project? I've said phone tool. What type of application do you want to make? And it will give you a choice interactively of lots of different types of applications. So maybe you want to write something that just listens to a queue and processes a queue. Maybe you want an application that's load balanced and auto-scaling. So that's what we select here. And this CLI will work out the details for you. We give our application a name, and that's it. Once that's done, we can start developing our application. It will create a config file for us where we can tweak things like the amount of memory and CPU. We can turn on and off logging and whether it has a public IP address. So really nice, simple, easy to understand configuration file. And then at some point during your development, you're going to want to deploy this somewhere. You're going to want maybe more services. So at the moment, we've just created one application, our front end. Maybe we want a back end application in that same project. And we want them to be able to talk to each other. So with this CLI, you can create multiple microservices or services within a project. So if I run that same init command again, it's going to say, hey, look, you're already part of a project called Phone Tool. do you want to create a new service within this project? And we'd say yes, and again, tell it what kind of service we want to create. We'll go ahead and do that. Then we want to deploy. Normally, if I'm doing deployments, I don't just want to deploy straight to production. I want to deploy to staging, and then I want to deploy to production. And actually, I just want to do that with a Git push. I don't want to mess around with infrastructure here. So this CLI tool will automatically build out for you a staging environment, a production environment, and it will automatically configure code pipeline for you so that you have a CI/CD pipeline out of the box for your application. So there's a command called env init. So there's a question there, how did we pass the YAML file? So it was this YAML file I think you were referring to. This is automatically generated for you, and it sits in the file system alongside your project. So this tool allows you to create new environments. So I run the command tool and then env init, environment init, and this will automatically create all the infrastructure I need. So a VPC, an ECS cluster, a load balancer because it knows I need one, a container registry, etc. It will then deploy that environment for me, but I can also deploy a production environment. So a really common scenario is that you want a development environment that's kind of cut down. You don't want to be the same for your development environment as you do production. You maybe want less resiliency, less power. So there's also an option to create a production environment. And this will create the same things, but also some additional protections. Things like termination protection to make sure it's not accidentally shut down. Things like deploying across multiple availability zones in AWS, so you get multiple data center resiliency. When you're ready to deploy, you can deploy your application with a single command. Yeah, let me just take a second to mute this. Sorry, everyone. I think I'm the only one who can mute people here. Okay. Hopefully that's better now.
There was a question.
I think I answered it. So now when you're ready to deploy your application, there's a single command to deploy it, and you just specify which environment you want it deployed to. But I mentioned a minute ago, most developers won't want to be interacting with the CLI tool every time they want to deploy. You want a CI/CD pipeline. You want to be able to just push your code into your repository and have it run down and automatically deploy to staging, run tests, and if tests are successful, pass it on to production, maybe with a manual approval gate if you want in there. Continuous delivery is kind of the term that this would come under. And again, it's just one command, pipeline init. And this will automatically create a full CI/CD system layout and code pipeline for all of your applications and your environments. So this really makes developing applications very, very easy with ECS. And as I mentioned, I think it's the easiest way to get started with containers on AWS today. Okay, so we've talked a bit about ECS, which is one option for deploying containers on AWS. At AWS, we want to give you the choice. We have some customers that want to use ECS. It has a lot of very strong native integrations with AWS. We have some customers that prefer the open source technologies and would rather use something like Kubernetes. So I want to take a few minutes and talk a bit about Kubernetes on AWS. First of all, I want to show you how to deploy Kubernetes on AWS. It's one command. This one command uses a CLI tool written by a partner of ours, Weaveworks, and us as well, AWS, and a whole bunch of open source contributors. And it really is an easy way to deploy Kubernetes on AWS. And I can run this command, EKSCTL, create cluster. And I can add the flag managed at the end, and it will deploy for me a whole Kubernetes cluster with a managed control plane that takes care of, auto-scaling, resiliency, all that kind of stuff, and also manage worker nodes. And we'll talk a bit more about that in a minute. But this is just one command to create all that. Let's step back a tiny bit, talk about EKS in general. When we launched EKS, our managed Kubernetes offering, we've got a couple of core tenets that we wanted to keep to with this. The first one is that our managed Kubernetes offering should be ready for production workloads. And in fact, we have some huge customers using Amazon EKS today. When we deploy an EKS cluster for you, this is a single tenant cluster. This is not a cluster you're sharing with someone else. And it's automatically multi-availability zone, highly available architecture by default. We're confident that we're able to run this service reliably, and as such, we've included an SLA with it. Something that is very important to us and our customers is the idea of Kubernetes in EKS being native and upstream. So conformant with upstream Kubernetes, not a fork or clone of Kubernetes that looks like Kubernetes but isn't really. It's some Amazon fork of Kubernetes. EKS is upstream Kubernetes. What this means for you as a customer is that there's a whole bunch of tooling out there in the marketplace for Kubernetes, and it will all work. And it will work with your EKS Kubernetes cluster. As part of this work, this obviously means that AWS is committed to contributing back to open source. And as part of the work with EKS and containers, we've contributed to over 30 different OSS projects, including Kubernetes itself, improvements, security patches, bug fixes, etc. A lot of that work is around making sure that Kubernetes has seamless integrations with the AWS platform. So things like allowing Kubernetes to spin up a load balancer, for example, or an application load balancer in AWS, or allowing you to put IAM roles directly onto containers and pods. Okay, so with that in mind, let's go back to this slide I showed you a minute ago where we talked about, how to deploy a cluster. If you haven't seen this EKSCTL command before, I recommend looking it up. It really is very easy. You can also get more advanced with it. I can create a small YAML file that describes my cluster and kind of the configuration, some more advanced configuration. And I can save that YAML in version control, and I can create clusters over and over again. And this way I get extra configurability and repeatability. Let's have a look at what it deploys for us. So here you can see a couple of different VPCs. The one on the right is your VPC as a customer. So this command will deploy auto-scaling groups of Kubernetes worker nodes into your AWS account. The VPC on the left sits within one of AWS's AWS accounts. And this is where your control plane will be deployed. And we deploy behind the scenes for you a control plane that spans multiple availability zones, so data centers, and has high availability and scaling built in. When we launched EKS, phase one for us was always about management of the Kubernetes control plane. There's a question there about sharing slides. Yeah, we'll share slides in PDF form at the end after the event. So phase one for us was always about management of the Kubernetes control plane. We launched that, and then phase two was about management of the Kubernetes data plane. So when we talk about Kubernetes, the control plane and the data plane are the instances or compute where your containers actually run. And we knew for phase two, there was a bunch of improvements we wanted to do here. And I want to talk you through some of those launches that have now happened. So the first launch was EKS managed node groups. Previously, before this feature, when you spin up Kubernetes clusters and worker nodes, you would have been responsible as a customer for deploying those worker nodes and keeping them updated as well in your AWS account. This was clearly some heavy lifting that we didn't think customers wanted to be doing, and something that we could take on for the customers and for you. So we launched this idea of managed node groups. And here's the console for EKS. And you can see here at the bottom for this cluster, I've got two node groups deployed. In my case, I wanted different node groups. I wanted one of them to have encrypted EBS volumes so that anything deployed on there would be encrypted at rest. And then I've got another node group that isn't. So EKS is deploying these node groups for me. It's creating the auto-scaling groups and EC2 instances in my AWS account, and it's managing those for me. So it will also manage the upgrades to those worker nodes. So you can see here at the bottom, my encrypted node group has an update available to the version of Kubernetes. So I can just click Update Now, and this will go ahead and safely upgrade all my Kubernetes worker nodes. So this is a really nice improvement for customers running Kubernetes. Okay, next up I want to talk about an even cooler, in my opinion, feature for EKS. And I want to lead into this with a quote from our CTO, Dr. Werner Vogels. You should be able to write your code and have it run without having to worry about configuring complex management tools. If I'm a developer building an application, I don't want to have to spend time thinking about infrastructure and worrying about scaling, etc., and patching operating systems and all that kind of stuff. And this is the vision behind AWS Fargate. So AWS Fargate is a technology on AWS for running containers in a serverless fashion. You give us your containers and we'll worry about the infrastructure. We'll worry about the scaling of that infrastructure. So we've launched Amazon EKS on Fargate. And what this means is if you have a Kubernetes cluster on AWS, when you deploy, you can choose, do you want your pods, your containers, to run on Fargate? Or do you want them to run on EC2? And if you choose Fargate, you get this really nice experience of not having to worry about infrastructure. So you can take your existing pods, your existing Kubernetes YAML files, and just to choose to deploy them into Fargate. And you can do this by selecting rules within your EKS cluster to say, okay, if I deploy to this namespace, then it should be on Fargate. Or if I deploy into that namespace, then it should be on EC2. And you can even get more granular if you want and say, okay, these services should be deployed onto Fargate. Behind the scenes, what will happen is Fargate will find compute for your containers to run on. You won't have to think about it. It will just happen behind the scenes. We worry about things like making sure your application runs spread across different availability zones and data centers for you. And we also worry about the right sizing and scaling so that you don't have to scale up your infrastructure. So you can think of Fargate as a serverless compute platform for containers on AWS. Multiple orchestrators can be used. So customers using ECS can deploy onto Fargate, and customers using Kubernetes and EKS can deploy onto Fargate as well. It's an underpinning technology for our container services. So if we go back to our previous diagram, right here we've got our EKS service, and this is where we had the managed worker nodes and EC2 nodes running in our AWS account. What Fargate does is it gets rid of those worker nodes. It means that you don't actually have any, have to provision any infrastructure in your AWS account. What happens is your containers will run inside the AWS Fargate AWS accounts. They'll create a cross-account network interface into your VPCs. So for all intents and purposes, that application will look like it's running inside your VPC, your network. It will have IP addresses in your network. But actually, you haven't had to think about the compute at all. So let me try and make this a bit more concrete with a demo of Fargate. So here, if I open up my terminal, how's my terminal size? Can you read that? Let me make it a bit bigger. Okay, that looks good. So I've got a Kubernetes cluster up and running. And this is just kind of the default cluster. The way I create it was eksctl create cluster -- Fargate. And this will create with one command a Kubernetes cluster with Fargate enabled. And that's all I've done before this demo. So if I look at my Kubernetes cluster, and I look at what's running on my Kubernetes cluster, all that's deployed on here are the kind of core DNS services part of Kubernetes. Let's deploy, if I look, I can also see get nodes, and I can see here I've got 2 nodes. So one key thing with Fargate and EKS is it will spin up a new node for every pod that gets deployed. And this is really cool because it means you're getting hypervisor level isolation for your container workloads. So really nice security benefit. Your containers will not share the same underlying host kernel as any other containers. So really good isolation properties. What I want to do here is show you how I can scale up and scale down with Fargate without having to scale any infrastructure. So I've got this basic Nginx deployment with Kubernetes, and it consists of a Kubernetes deployment, and it's called Nginx, and it deploys the Nginx image. It listens on port 80, I've then got a service with a load balancer in front of these containers. And I just pass in an Nginx configuration file, which just makes configuring Nginx a bit easier. That will get mounted in the file system in the container. So you notice here I've got replicas. In Kubernetes, this is how many of the container I want running. So here I'm telling Kubernetes, I want 50 Nginx containers running, please. So if I apply this to my cluster, okay, this has created that service, it's created the deployment, and now if I do a kubectl get pods, I can see I've got these 50 Nginx pods waiting to start. Now this takes a little bit of time. It's a little bit longer to start a container than if you were hosting the worker nodes on EC2, for example. So Fargate does add in a small delay starting these containers while we go away and we try and find compute resource and we allocate that to run your containers. So roughly 30 to 60 seconds, that kind of time frame, depending on the container image size that needs pulling. And if I look at get deployments, we can see here we've got none up and running so far, but any second now, these should start jumping into life and they'll all start very quickly. So if I just show you quickly what this looks like in my AWS console. In my EKS cluster, I've got this configuration that allows me to define where my containers run. Do they run on Fargate or do they run on EC2 nodes? So this is the profile I've created here. And it basically says, if anything is running the default namespace or the kube system namespace, run it on Fargate. So that's how we decide which applications run on Fargate and which don't. And you can also set up here in that profile which subnets they should join into, for example, those containers. So now if I go back here, I can see my containers are starting to fire up now. So it's taken around 60, 90 seconds, and I've already got some containers running. If I look here, I see 5 up and running, and very shortly, these will start increasing up until we've got our 50 up and running. What's interesting here is I haven't had to deploy a single instance. I haven't had to deploy any infrastructure at all. This is all managed for me by AWS. And it's even quicker when scaling back down. So I can still use technologies like the horizontal pod autoscaler to scale up and down the number of containers I've got running automatically. And this will scale down the instances automatically for me. So really, really cool technology here for running Kubernetes in a serverless way. Okay, so just to kind of reiterate what we've gone over there, there's some really nice functions of Kubernetes and Fargate. You don't need to worry about things like worker nodes anymore. You don't need to pay for any unused capacity there. And also you don't need cluster autoscaler. So in Kubernetes, there's an open source plugin called Cluster Autoscaler. And it's what most people use for scaling in and out their compute nodes on Kubernetes. And it works by watching the Kubernetes scheduler. And whenever it sees a pod that can't be scheduled due to a lack of resources, CPU or memory, Cluster Autoscaler will adjust an autoscaling group and add capacity. So it's a really, really common and popular option, but it also comes with complexity. So it's nice with Fargate that you don't even need that. I'm sorry, Osama. I'm going to decline that. Okay. Next, things you get out of the box. So I mentioned that VM level isolation at pod level. Traditionally, if I'm deploying Kubernetes, all of the containers running on a single host will all share the same operating system kernel. By isolating with Fargate, every pod, every container gets its own operating system kernel, which gives a huge increase in security. You also get things like pod level billing and service level billing, which makes cross-charging in an enterprise much, much easier. You know, if you're the sort of organization that wants to say, okay, hey, team, you've used this much compute resource this month, there's your bill, and do internal cross-charging, that's much easier with Fargate. There are some limitations to Fargate today. So you can't use things like daemon sets. So in Kubernetes and containers, daemon sets are where, for example, you have 10 hosts and you want to run one of each container, you want to run one container on each host. And daemon sets are often used for things like monitoring or logging agents. That doesn't make much sense in Fargate, where every single pod that comes up is its own node. Today, you're also limited. You can't use the load balancer service type. You can't run privileged containers, and you can't run stateful workloads that need disk volumes, so persistent disk volumes. If you have requirements that need those things, your best bet is still manage worker nodes. It's not a bad choice. But for options for containers and workloads where you don't need those things, Fargate is a really, really nice, easy option. A few things to keep in mind. With Fargate, there is a soft limit of 100 Fargate tasks or pods per region. If you're playing around and you see this, don't worry. You can increase this limit. Just open up a simple support request to AWS and that will be increased for you. I mentioned earlier that every pod gets its own node in the cluster. And this does bring in another limitation that Kubernetes is tested up to 5,000 worker nodes per cluster as an upper limit there. So we don't recommend using 5,000 pods or more per cluster. For most customers, this isn't a challenge at all. You know, a lot of customers aren't going to hit those kind of numbers. If you think you may hit those kind of numbers, speak to us, speak to myself, and we can show you some architectural patterns that can help there. So you saw that when I started a pod, the start time was a bit longer on Fargate than EC2. You saw that kind of 60 to 90 seconds in my demo there. I've seen it as low as 30, etc. It does vary a bit there. But it's worth bearing in mind that actually if you're scaling up by a lot, this may still be quicker because those containers will all start at once. It happens in parallel. If you compare that to the way that cluster autoscaler on EC2 would work, that would request some capacity, fill it up, request some capacity, fill it up. It actually means you can scale up faster in a lot of cases by using Fargate. So pricing for EKS is a standard price of 10 cents US per hour. And that doesn't matter what size your control plane or cluster size is. There's standard Fargate pricing for CPU and memory for your containers that run. There's a few links here, kind of next steps if you want to play around with Kubernetes. We'll send out the slides, but this is the slide to take a screenshot of if you wanted to make a note of it now. So EKS-CTL is the command line tool for spinning up clusters. We also have a really nice workshop that's available online and covers a whole ton of Kubernetes teachings. So if you want to upskill, if you want to learn more about Kubernetes, check out this free workshop that you can run through. The other thing I wanted to call out is our containers roadmap. So the containers team published their whole roadmap on GitHub as like a Kanban board. So in this, you can see stuff that we're working on, stuff that's in design proposal stage, and you can get involved and have your say on how our services should be built. So check this out as well, especially if you're running containers on AWS today. Okay, let's take a second. I'm going to have a sip of water on my desk. And maybe look at questions, see if we've got any questions here at the moment before we dive into the next section. No, nothing here. Okay. All right, so that's containers covered. Hopefully that was interesting for you if you're thinking of using containers or already using them today. If you don't care about containers, I'm sorry if that wasn't very interesting for you. Okay, let's talk about serverless and Lambda. So Lambda allows you to deploy functions onto AWS. It takes that unit of compute down a size. So when I started in IT, we deployed, physical servers in data centers. Then things like VMware came around and virtualization, and we managed to shrink that unit of compute down a bit more and make it a bit more flexible. Then things like containers came out. And with containers, again, you're shrinking down that unit of compute, making them a bit more agile, a bit more easier to spin up and move around. Functions with Lambda is the next iteration of that. Taking that size, that bit of compute down to the smallest level. So you're able to take your functions and deploy them into AWS. And we're going to go through, and I'm going to show you a demo of doing this in a second. We added at reinvent the ability to provision concurrency on AWS Lambda. When you're using AWS Lambda normally, what Lambda will do is behind the scenes automatically, when your function is invoked, it will spin up compute behind the scenes. It will allocate that compute to your function automatically. And you'll be able to scale up and scale down in a very serverless way without thinking about that scaling capacity. What we heard from customers is in some advanced scenarios, customers want more control and flexibility there, and the ability to actually say, hey, I want you, AWS, to keep a certain amount of capacity warm for me so I get even faster startup times to my function. So this is some functionality that I probably wouldn't recommend you starting with if you're brand new to AWS and Lambda. It definitely falls under the more advanced functionality. But if you're in that situation where you want super fast startup times, this is a really good option to give you more flexibility and control. The next thing I want to talk about is event sources for Lambda. So when you deploy your function into AWS with Lambda, one of the really cool things is the ways that you can trigger your function. So Lambda has this concept of events, and you can trigger your function off a whole lot of different events in AWS. So maybe, for example, you want to trigger a bit of a function whenever you upload an object or a file into S3. You can do that, and you can connect Lambda to S3. Another really common use case is connecting Lambda to a HTTP endpoint. And what this means is you can very quickly build kind of APIs. And I could have an API that has, /customers, /products, /users, for example. And each one of those could go to a different Lambda function. Well, the way you do this in AWS is with a service called Amazon API Gateway. And traditionally, Amazon API Gateway has had this functionality where you can do this, but it has a whole load of optional extras. So things like maybe parameter verification within your requests and responses. So making sure that all the requests in are valid requests. Things like is the user's age a number, for example, and not a string. So it can do these validations. It can also do some more advanced things like create usage plans for your APIs. So maybe you have a gold plan for your API where people can hit it 1,000 times a day or a certain number of times a month, and their transaction rate is this many transactions a second. It also has functionality around things like request and response mapping. So maybe I'm writing a service that talks JSON, and I'm talking to a backend mainframe API that talks maybe SOAP, XML. So API Gateway can do that translation on the fly. So traditionally, API Gateway has had all this kind of advanced functionality, and a lot of customers fed back to us that, hey, this is cool and all, but we're not using it. We just want to be able to front a Lambda with a HTTP endpoint. And so what we came up with is this idea of a cut down HTTP API for Amazon API Gateway. And this gives you some of those functionalities like building a HTTP API, but without some of the bells and whistles that the RESTful APIs come with. So this will allow you to reduce your costs a lot and also reduce latency of your applications a lot. And I'm going to show you exactly what this looks like in our AWS console. So this is our Lambda console if you haven't seen it before. This is where I can go and create AWS Lambda functions. And what I'm going to create within about 5 minutes here, maybe less, is an API hosted in Lambda and available online. So I'm going to create a new Lambda function. I'm going to start from scratch. I could use a blueprint, or I could browse existing applications that other people may have made. But I'm going to go from scratch here. And I'm going to create an API, and one of the API endpoints on my API, I want to call products. So this will be the endpoint /products on my API. And my Lambda function here will return a list of products. So I click create function. And then this is going to drop me into an editor where straight away I can start writing my function. I'm showing you here through the console, through the web console. We obviously have CLI tools, we have APIs, we have integration with your IDE, for example, that you can use here as well. This is just a nice way of showing you so you can get an idea of the functionality. So we've got our function here, products. And we can see the code for it. And because I chose start from scratch, this is really, really basic. It's just going to respond with a 200, and it's going to respond with this text. So let's change this. Let's respond with a list of products. So here, I'm going to do ID 1 and name bowl. And then I'm going to have another product, ID 2, name plate. Okay, so let me save this now. And then the next thing we're going to do is attach API gateway in front of it. So I'm going to add a trigger for my Lambda function. And you can see here I can select from a whole bunch of different sources. These are the events for the Lambda function. So I can choose to write something that integrates with Amazon Alexa, for example, or something that triggers off of maybe a third-party event like Auth0 or Datadog. In my case, I'm going to choose API gateway. And I'm going to create a new API. So this will be the API for my whole organization. And I'm going to call it, let's just call it API. And I can do things like enable cores. I can also do things like add authorization as well. So it'll integrate with OAuth 2 authorization systems. So while HTTP APIs are cut down in terms of some functionality, they still allow authentication. They still allow most things that you'll need for developing a simple RESTful API. So here we are. We've just attached this trigger to our Lambda function. And in a browser, I should be able to open this up now.
Because it's 20% step for the Python. So try to do it tomorrow morning before the exam better. But now focus the whole day.
Sorry, I can't see who that noise has come from. If you message me the name of the person, I can mute them. Okay. So Lambda and API Gateway have given my API a public URL, and I can hit this URL and straight away I can see my API that I've created. So really, really cool. And I can also create more and more Lambda functions and add them into that same API at different URL endpoints. So this, in 2 or 3 minutes there, I'm able to create an API hosted by Lambda that's production ready. I get things like monitoring out of the box so I can look at metrics and insights into my applications and logs. I can set up alarms for failures, etc. This is a very, very quick and easy way to develop applications on the cloud. Okay. Let's talk about step functions. When you're developing an application on AWS, as a developer, you often find yourself building processes, right? So what step functions allows you to do is create processes outside of your application. Let me give you a concrete example. Imagine the scenario where we wanted to receive images from our users, our customers, and we want to extract metadata from those images. As a developer, it would be super tempting for me to write this all in my application. Things like extract the metadata from the image, check whether the image is a supported image type. Maybe we only support JPEGs. Take out the metadata from the image. So, the camera type, the focal lens, etc. Maybe run it through AWS recognition to find out what's in the photo. Does it have a beach? Does it have sunshine? Does it have a person? Are they happy? Are they sad? These are all things you can extract with recognition. Maybe I want to take a thumbnail as well. And then I want to take all of that, if it was successful, and store it in a database somewhere, maybe DynamoDB or RDS. So I could write this all in my application in Python or Node.js or whatever I want to use. But I'm going to have to do quite a bit of safety checking as I go along there. What happens if halfway through there's some sort of failure? What if I can't access recognition at that time, or it throws back an error? As a developer, I'm going to need to do things like implement retries and back-off policies. I'm going to need to monitor these and work out which ones have failed and why, and alert on those. This is quite a bit of work for a developer, and this is a fairly simple example. I bet if you look inside your applications, you'll see they're all made up of these processes. What step functions allows you to do is take that out of your applications and simplify your applications. So all of the green boxes you see here are actually individual Lambda functions. And step functions controls the orchestration and the running of these Lambda functions. And it aggregates and runs and checks results. And it can also do automatic retries for you and back-off handling and error reporting. With step functions, I can actually go back and look at all of the previous executions of my state machine here and look at their status and where they failed and see in a very visual way what happened in my application. So you can think of step functions as a way of doing resilient application development very easily. We launched step functions quite a while ago now. It's been around for a long time. But it wasn't amazing for scenarios where you had a really high transaction throughput. So maybe you've got hundreds of thousands of events per second that you want to trigger a workflow for, high volume scenarios. Or maybe you want very, very low latency responses. We launched the idea of express workflows that fit very well into this scenario of high transactions per second, but shorter duration on the workflows. And they allow you to operate at a much better cost efficiency scale. So if you've got this kind of workload, I advise you to have a look into step functions, especially the express workflows if you've got that high throughput requirement. The next thing I want to talk to you about in the serverless space is something called EventBridge Schema Registry. So when you're doing serverless development with Lambda, what you'll tend to find is that your Lambda functions are triggered by events. You saw that in the demo that I did, right? We had S3 as an option. We had HTTP endpoint as an option. These events come into your code within Lambda, and they may have lots of different fields, like maybe if it's someone's name being sent to us, it has a first name, it has a family name. These event schemas normally are quite hard to document. They're normally quite hard to find out and discover. EventBridge Schema Registry is a way of centralizing all these definitions of your schemas, of your events. And these could be events from AWS, events from third-party SaaS providers and AWS partners. So Datadog, for example, maybe they send events to your Lambda function. What does that event look like inside? How do you find out what fields there are going to be? But also for your own events as well. So if you're sending your events through EventBridge, it has a learning mode where it can automatically watch all the events flying through your system. Normally you'd do this in a development environment, and it can learn about the schema of these events. And what's really cool is it can automatically build for you an SDK of your events. So within your own programming language, you get things like autocomplete on all the fields in those events, both of your own custom event schemas and also the ones from SaaS providers and AWS. So this is really core and interesting functionality for those developing serverless applications, and it really helps as you scale up your serverless usage. Okay, let's talk about mobile app development. For a while now, AWS has had a service called Amplify. And Amplify makes it really, really easy to host web applications, things like blogs, maybe static HTML blogs with things like Hugo, for example. You can just one click within your repository of your Hugo app. You can just, one command, and it will create a pipeline and host it in AWS for you. It also Amplify makes it easier to develop applications for web and mobile. And historically, before reInvent last year, that was limited to kind of hybrid mobile apps with React Native. The feedback we had from customers was that while some customers were okay with that React Native hybrid app experience, other customers wanted a more native iOS and Android application approach. So what we've launched here is a bunch of SDKs and libraries that allow you to really easily in your mobile application or web application include some really cool and advanced AWS functionality. Things like authentication or storage. So here's an example. I'm not going to run through this fully, but if I have an iOS application or an Android application that I'm developing, I can run this amplify init command and it will auto-detect my application. I can then add things like storage or authentication. And in this case, when I add storage, it's going to run me through a wizard like, hey, Paul, what do you want to store in your mobile application? In my case, I've said images, audio, video, And then it asks me, do I want to add authentication? So these images, videos, etc., that mobile phone users are uploading into my application, should they be restricted? Should they be locked down so that only authenticated users or only the person uploading the image can actually view it? In this case, I've said, yes, I want authentication in my application, please. It asks me which S3 bucket I want my images to be stored in, who should have access, etc. And then this will go away and it will build into my mobile application this functionality. So here's an example of the sign-in screen that's provided by default. You can customize this and add your own, branding into here, but it will automatically configure authentication for you. It will provide a screen that you can just defer to in your iOS code to run the user through a login sequence or even a sign up forgotten password sequence. So really, really cool functionality. Very, very easy to have some really advanced functionality in your applications without much effort at all. So if you're into mobile application development, I encourage you to check out AWS Amplify. Another bit of functionality that was added to Amplify was the ability to synchronize data. So in this day and age, it's very, very rare, especially for us geeks, that we've got one device. I know about you people on the line, but I've got a mobile phone, I've got a laptop, I've got an iPad. And if I've got an application on those, in this day and age, I expect that application to stay in sync between my devices. Amplified Data Store is a solution for doing that. So what it can do, let's go with a concrete example. Let's say I've written an application that allows you to read books. And if I start reading a book on my iPad, I want it to save the page that I'm on. If I open up the application somewhere else on my laptop in a browser, it should remember that page. This functionality with Data Store will do that for you and it will take care of all the synchronization. But what's really cool is it will handle automatically conflict resolution. So let's say I go on an aeroplane. I'm a good citizen, so I put my phone in airplane mode. I don't think I do that normally, but for this example, I put it in airplane mode. And I've also got my iPad in airplane mode. And I switch between the two. When my phone runs out of battery, I carry on reading on my iPad. Neither of them have got connectivity. When they both get connectivity again, they're both going to try and upload into the cloud to say, hey, pause on this page. No, pause on this page. What Amplified Data Store will do is it will handle that conflict resolution and it will look at who is the last person to update. What was the timestamp there? And it will handle that whole process for you. So really, really interesting. It does delta syncs and auto merging as well. Okay. At this point, I want to thank everyone for staying with me during this. I hope this has helped inspire you, and it's a real whirlwind tour over our services, and we've talked about an awful lot. But hopefully when you start building applications, when you start deploying applications, you remember some of these slides and you think, oh, that guy from AWS, Amber or Paul, he said something about this. Let me go back and have a look. And I've just got it in your head that we have a lot of services that deal with a whole load of different use cases to help here. If you're ever in doubt, reach out to AWS as well. We're more than happy to help you and advise you on how to use these services. So at this point, I want to say thank you again and just open up to any questions. No questions?
Can we do stuff without code?
Can we do stuff without code was the question.
Maybe there's more to come.
Yeah. In general, so an example, store a file to S3 using API gateway. You can. There is a way of configuring API gateway to directly forward requests for a certain API endpoint to other AWS services like S3, for example. So that way you could use the AWS SDK in your client, your web app, or wherever your end client is, and have it push into S3. Honestly, I wouldn't recommend doing this, especially in your S3 use case here. What we tend to recommend to customers is if you have, let's give an example. If I've got a mobile application and I'm expecting customers to upload an image from the mobile application into my backend. If I was to send that request through API Gateway and into S3, not only am I paying for API Gateway and adding additional cost, but it's also sitting in the way. Right? So it's an extra hop that file, that traffic needs to go through. So it's going to impact performance. It's going to add additional cost. The general advice is if you have mobile applications, web applications, they want to upload to S3, have them go directly to S3. And you can do some interesting stuff there, like as an app developer, you can create a pre-signed URL that can be sent to the client that is like a one-time URL for uploading to a specific place in S3. So that way you can do it securely. So we'd always recommend going straight to S3. To kind of step back a bit to your question, you know, and away from that specific example, stuff without code. I think our approach at the moment is less code, not no code. I think it's fair to say. We do have some services that can ingest data and move it around without writing code, like Kinesis Firehose, for example, can automatically batch up data and save it to S3. But in general, most things can be solved with a Lambda function and a very small amount of code. Yeah. So we also share a whole bunch of examples. So if you look in Lambda, there's a serverless application repository with lots of applications that people have already written before, common use cases. At AWS, we also publish to GitHub a lot. You know, so we have people like myself and the others in the room here, lots of people in AWS all contributing examples and open source code. So if you look in the AWS GitHub, there's a GitHub repository called AWS-samples, where you can find a bunch of example code. Okay.
Thank you, Paul.
Doesn't look like there's any more questions. So thank you very much for your time. And keep in touch if you want to learn more about AWS services. We're going to be sending out the slides in PDF format and distributing them tomorrow. We also have another session tomorrow. Same time, same web conference system. And in the session tomorrow, we're going to be talking about things like databases and analytics, and also machine learning and artificial intelligence. So really interesting one. Okay. Masalama. Thank you, everyone. Shukran.
Pizza time.
Is the event approach actually doing